can run like state level. So, it's a team. It's real. I do like yeah, I know that. It's like actually it's a okay counselor, but I don't even have a good one where I have a 144 13, which is like a really good one, but it goes like like my fellow phones. I did not.
I wonder
We did not. Wait, that's my first meeting last time.
You just got really strong
On the dump.
for 2.5 days. 2.5 days. And then we don't get a break until February, and we don't get a break till April. And then summer. That sounds great. I can't wait. Oh, my opinion, second semester. My grades, it's not. It's like my policy is all over. And
So, I had a nice.
second semester, but my really worse.
Bro, I was picking up for first semester. You go, I need to work. Yeah, third day of the world. Okay, we have 9 minutes. Let's go. 9.7 hours, and then these are gonna be like fun. Oh my gosh, no, not these.
Okay, let me go over the calendar here. So we have a FRQ test coming up on Wednesday. It'll look like so first off, we're going to finish up page 22 to 24 from your previous packet, and then you guys picked up worksheets 5 and 6. And this is basically what your test will look like. It'll just be front and back. And so we should feel pretty comfortable by Wednesday, since we're going to kind of just cycle through these types of problems. Okay. You will get to use your calculators, but I do need to see all your steps. Let me show some. Yeah.
What about all the homework? I'm a bit lost as to like where I am.
Yes, I think you have all the homework,
Okay.
but I'll let you know though if there's any.
Thank you.
Okay, so that'll be Wednesday. We'll spend we'll spend today and some parts of tomorrow continue review. I'll also have a Wednesday morning help session going over worksheet 6. So that'll be what you can expect for Wednesday. Any questions about that type of the format there? Okay, so after that, we're going to, I'll give you another packet, which will just have a combination of FRQs that you've seen before, Riemann sums, differential equations, rate in, rate outs. Rate in, rate out is what we started at the beginning. Beginning of packet, the previous packet had all those rate in, rate out problems. We'll continue to practice those. So we'll have Thursday, Friday, and Monday to review. We may even start it tomorrow as well. And then that'll be a quiz grade. And it'll just be 3 FRQs, Riemann sums, differential equations, and rate in, rate out. Okay. And then finally, I have one more assessment for us, and that is going to be a multiple choice quiz. So we'll spend most of next week reviewing those AB topics from this semester. And this will be a partner quiz that Monday before that Monday of that last week. Okay, so it'll be 14 multiple choice questions, but you can decide, well, I need to know how what format you would like to have it as. So everyone can decide. So if you want to just take the quiz solo, then you'll answer 9 problems, but you'll get to omit 5 problems. Okay. If you want to work in a pair, then you'll answer 11 questions, and you'll omit 3. If you want to be in a group of 3, that's an option as well. You can, but you'll answer 13 questions and you get to omit 1. Okay. This will be AP curved. It'll be multiple choice, but I'll still offer partial credit if enough of the correct work is shown. So, and it'll be AP curved as well. So basically, if you can get 60% correct or around half, 60% correct, that is good enough for an A. Okay, and you get partial credit on top of that. So, so hopefully, that should be that should help us out. Okay. So I think starting like maybe next Wednesday or Thursday, I may ask you to send me a text remind so I know whether you want to take it solo, you want to be in the group, and if you're in a group, who's your partner, so that I can set up the quizzes and the room for that when we take that quiz on Monday. Okay. You'll get to use your calculators, but I need to see all your work. Okay. All right. Any questions with our remaining assessments? Also, these two, the test and the quiz, I'll also offset the grade with homework grade as well. So, so basically, if you show me all the homework from packet 1, that'll count 50 points towards your test grade. And then, and if you show me all the the next packets homework on time, that'll also count 50 points towards your quiz grade as well. And then all the homework from the multiple choice packet, that will go towards your partner quiz grade as well. So I'm kind of working in the AP curve through your homework grade. Okay. And you'll get to use calculators on all 3 of these assessments. Any questions? Okay. All right, let's go to page 23 from your previous packet. Okay, so part E, this is page 23 here. Part E says, is there a time C in the closed interval where G triple prime of C is equal to 2/5? But if you look, we don't have a table of values for G triple prime, but we do have G double prime. So the connection here is, well, we know that G triple prime is referring to the derivative of G double prime. So if I can show that the slope between the 2 points of G double prime is 2/5, then there must be a place where the slope of G double prime is equal to 2/5 as well. So this is basically an application of mean value theorem. So let's go ahead and state our conditions. We know that everything up to G double prime is differentiable. So we know that there's not going to be any holes or asymptotes. Our function is going to be continuous and differentiable. So let's go ahead and state that. We know that G double prime is continuous. Differentiable. Continuous is with brackets. Differentiable is with parentheses. So this is an extension of mean value theorem. Normally, mean value theorem looks like this, right? F of B minus F of A equals F prime of C. But we can have this all go down one derivative or two derivatives, actually. And we can say that F double prime of B minus F double prime of A over B minus A is equal to F double prime of C, right? So this, it's the same thing as this. It's just everything is shifted down one derivative. Not the second.
No, I grabbed it.
You got it? Yes. Thank you. So let's go ahead and find those values. So we can do F double prime of 6 minus F double prime of 4 over 6 minus -4. And if I can show that this has a slope of 2/5, then the curve, this G double prime curve, must experience that 2/5 somewhere along that interval as well. So we look at our table of values, we get 2 minus -2 over 10. That does equal to 2/5. So because my G double prime graph is experiencing 2/5 between the two endpoints, there must be a place where the slope of my G double prime graph is also equal to 2/5. We can say by mean value theorem, there exists a value where G triple prime is equal to 2/5 on this G double prime graph. This is, if you don't have it, that's why you use that one. Okay, try part F. Part F says, let F be a function defined by K of X, find K prime of 3. So we have to go through a series of chain rule to build K prime, and then we can plug 3 in, and then we can use a combination of the graph and the table of values to make substitutions. Okay, try that. So you gotta take turns with each portion's derivative. There's three different levels here. You got G prime, which is the outermost function. You got the bracket, which is F prime minus one. And then you have the innermost portion, which is 2x. And each portion will have their own space for their derivative. And so G prime becomes G double prime. We keep everything inside that G double or that bracket intact. And then next up, we move on to F prime minus one. F prime minus one is derivative of F double prime. We keep the 2x intact, and then finally the 2x gets its own derivative space. 2x becomes 2. Right, this is the most important part of this problem here, building out that derivative, because after this, we're just making substitutions and trying to get it down to a number. Any questions?
The part D, did G double prime of -4, was that, oh, never mind, I'm good.
Yeah, so that's just from the table.
Yeah. You know, like state be like this.
Yes, it'll be like this, yeah. And then the additional handout that you got is also similar. Yeah, it'll be this format, yeah. You get a table of values, you'll get a derivative graph, and all these different sets of problems. Types of problems.
The chain rule, how do you know which goes where for like the formula? Like, how do you know it was G double prime, to the next one?
Yeah, so we're applying chain rule here. The chain rule looks like this. If I have the derivative of f of g of x, it's equal to f prime of g of x times g prime. So it's going to be this format here. So we're always going to take the outside derivative, keep the inside intact, and then we move on to the inside portion. Right. So here, my outside portion is g prime, so g prime becomes g double prime. And then the f prime 2x minus 1, that derivative goes here, and the 2x derivative goes here. So this is like a 3-layer here. This is only, the chain rule is only defined with 2 layers, but if there were 3 layers, then it'll be times x prime, times that inner function. Yeah.
So I forget the specifics of the with the general one.
For what?
EBT.
Yeah, I've got it. So extreme value theorem, we're trying to find the absolute max and absolute min. So you're going to test endpoints and test critical points, and then plug them all into the original function or whatever.
The initial function.
Yeah,
The
into the
endpoints and critical functions or critical
Points.
points are F prime.
right front into the original function, and whatever has the highest and lowest y values are your absolute max, absolute min. IVT is intermediate value theorem. That says if I have let's say f of 2 is equal to 6 and f of 4 is equal to 8, then I know that there must be some point. Let's say I'm trying to guarantee a y value of 7. If I'm trying to guarantee a y value of 7, I guarantee it if one endpoint is lower than 7 and the other endpoint is higher than 7. So IVT doesn't require any derivative or calculus, but it is still a theorem that is tested on the AP exam. Okay, any questions with part F? So part G says find the maximum value on the closed interval from -4 to 12. So this is an application of extreme value theorem. So extreme value theorem, we're going to test endpoints and test critical points. So your endpoints are going to be obviously -4 and 12. And then your critical points are going to come from your F prime sign line. Now, we already built our F prime sign line from a previous problem from part B. So we're going to get everything that we need from our F prime sign line. Don't look at F double prime. That's not going to give you any critical points that you need. So we're going to test -4 and 12. Now we're only looking for, do we need to test every critical point? Just what? Yeah, that's right, where F prime changes sign. So if there's no change in signs, we know that, I mean, you can test it, but they will never be your, then you're just doing additional work. So if you tested 2 and 10, you know, you wouldn't get points off, you just would be doing additional work. So you would test -2 because that's a relative min. Relative min could be an absolute minimum. And then you also want to test 6, because 6 is a relative max, that could end up being an absolute maximum. So we're going to test -4, -2, 6, and 12. Now, because this problem doesn't have a an explicit formula given to you, we have to build it from this application of first theorem. First theorem, basically, if I rearrange it, I can say any endpoint I'm looking for, any point I'm looking for is always going to be my initial point plus my displacement. So my initial point may not be the point furthest to left, but it's always going to be the point that is provided to you. So in this case, my initial point, my anchor point is f of 10. So if I want to find any point, I'm going to be starting here and then either moving left or to the right to get to my my destination. So I'm going to test -4, 12, and 6. The reason that I don't test 2 is because it's only asking for maximum value, so I don't need to test my relative minimum since relative min can't be my absolute maximum. So I'm just going to do f of b equals f of a plus displacement. So I'm going to do it for f of -4 because that's my endpoint. I'll do it for f of 6 because that's my relative minimum, sorry, relative max. And then I'll test for f of 12 because that's my absolute, so that's my endpoint. So if I want to do f of -4, I'm going to start at f of 10 because that's the point given to me. And I need to go backwards from 10 to -4. And because I'm going backwards, I would prefer to read from left to right. So after I write this down, I'm flipping the bounds, changing that to a negative so that everything that I see on my graph, I can just translate as positive and negatives and not have to think backwards. So then the accumulation of the area for the displacement from -4 to 10, I have -4, +8, +8, -8. All that is negated. So 5 minus 4 equals 1. Now I'm doing the same process for f of 6, repeat the same process for f of 12, and at the final, my final conclusion is based off of what I found with these numbers. The highest number is my absolute max, and I'm not looking for absolute min, so I don't need to include that. So my absolute max must be 13. And part H looks like a complicated problem, but it's meant to be a problem that we're forced to use U substitution so that we can get it to look like an integral problem that we have a rule for. So right now, this is too complicated, but we want to identify a potential U value where all the x's can cancel out. So if we target what's inside that cube root, if we let our U value be G prime of 2x, then the derivative should naturally produce G double prime of 2x, and we should be able to move our way to cancel out and get it down to a power rule problem. Okay, so try part H.
And do you know the relative max for G is 6 starting out? Okay, do you know?
Because from our slope sign line, we knew that this is the derivative graph here. So anything below is negative slope, above is positive slope, below is negative slope. So we created a slope sign line from part B. And from that slope sign line, we know that there's a relative minimum at -2, a relative max at 6, and endpoints at -4 total. And we're using kind of previous portions to help us through that EGT problem. So we let our U value be G prime of 2x, but even within G prime of 2x, there's a little bit of chain rule going on. So the derivative of G prime of 2x is G double prime of 2x times 2. Clean that up, solve for dx. To be able to get every x related information to go away, but there is a leftover 1/2 that needs to be pulled out in front. And then we can apply power rule. Once we apply power rule, make sure you bring the x back into your antiderivative. Then you can plug in your upper and lower bound. Once you plug in an upper and lower bound, you can replace your function notation from your table with numbers. And once you get it down to a number, you don't have to plug in the calculator. This is fine. This is an acceptable answer.
The test, if you're asked us to find the derivative, like integration or whatever, do we actually have to solve the whole thing and plug it in? Or can we just put the number into the calculator and be like math 9, math 8?
I want to. This is not going to be a math 9 problem. I do want to see you work it out. Okay, next page, page 27. So part I is average value theorem, finding the average value. So We want to apply average value theorem there. Okay, we're just finding the regions between -2 and 8, keeping track of our positive and negative values. Part J, find the average rate of change of f prime. So rate of change of f prime is just finding the slope between the two endpoints on the f prime graph. So we'll do f prime of b minus f prime of a over b minus a. This is average rate of change. The average rate of change is the slope of my it is asking for find the instantaneous rate of average rate of change or velocity is VFD minus VFA will do 1 second. Sorry, if I want to find it, if I want to find the average rate of change of velocity, that's the same thing as finding average acceleration. They mean the same thing. The last part here, finding P of 1, we can just rely on the displacement. And then for P prime, we have to do a little bit of a second theorem to get it down to P prime of X, and then we can plug in our X value.
Like for taking the derivative of the integration, there's one more false right? It's like that's what we have findings.
Right, yeah. So it was both the numerator, sorry, both upper bound and lower bound are both the variables. Then it's going to be minus f of q of x times q. We just repeat the same process for the upper bound, but with a minus sign. But if my lower bound is constant, then I can ignore it. That's just going to wash out to be 0. Okay, any questions? Okay, let's go to worksheet 5 and see if we can make progress on, that's the handout that you just picked up. Okay. Homework is to finish worksheet 5. Yeah, there's extra incentive for you guys to finish your homework on time since it's going to go towards your test and quiz grades. Okay, so let's spend 10 minutes seeing if we can get through the first page of worksheet 5. And that way you can just finish up the second page after home. And then the key is attached for worksheet 5. So try that. I'll come around if you guys have any questions. That's right.
So,
But I say
how do you recognize what's good for these?
H double prime is the slope of this, and H of zero is, I've used a displacement, so I have to use, this formula here. So final position equals initial plus displacement.
What's the displacement?
Displacement is just the area of the graph, in the graph to x-axis. So that fill in all these area regions there
Okay. So where did this two come
from here. It's given to us in the problem. Yeah.
So therefore, this would be good. Yeah, but we're not gonna see a C equations. I would, we know that. The only time we're gonna see speed is if it's like increase or decrease in speed. Then we're gonna compare something. And then we'll say, give one of the displacement versus displacement. The displacement is just the integration. It's just displacement, yeah, it's integral which from A to B. Of the velocity. It's the integral of the absolute value of velocity. From A to B, yeah. There are some AP problems that involves application of summation, but I won't focus on that. So we get closer to AP exams. Yeah, we won't see it. Yeah. Yeah. Yes.
I want to make sure that we can see this distinction in terms of the stem that's given to you on the reviews. Sometimes it'll just give you a point. It's always going to be a derivative graph, but sometimes if they give you a point, then you have to use this final equals initial plus displacement. But if the problem gives you a definition, then you're just relying on that definition, and you're not doing final equals initial plus displacement. So I want to make sure that we are comfortable with making that adjustment. So on the quiz, you may either see a stem where h of x is the integral, which is essentially just saying it's a derivative graph, but you're just going to rely on this to find any order pair that you're looking for. But if the order pair, if the formula is not given to you, then you'll just be given a starting point, and then you're going to use final equals initial plus displacement. Okay, so your homework is to finish worksheet 5, front and back, the keys attached. And then these homework are going to go towards your quiz grade, your test grade. Okay, so tomorrow we'll go over this, make sure you guys have any questions. I'm going to save worksheet 6 for morning review on Wednesday. So tomorrow, after you go through worksheet 5, I'm going to start looking at FRQs for your quiz, which is next week. Hi, can we for phones? That's points. So the homework is going to be 50 points, and then the kind of 80 points. I'm going to add them. Okay.
I started to help putting it in also, which were like, oh, I'm trying to know.
Oh, it's okay, so no, it's no time should. I don't think I did it right there. You want to do the quiz together? Oh, right. So prime is not a people valid, it's still, I don't have to. It's a short term, but a short term can still be a current components of.
It's like the main flow.
Yeah, so basically,
Yeah.
let's say.
Lawyer seat one day. We'll still do it.
Okay.
This
This
is
notebook seems kind of worth it.
I know, you're right.
Like the
Is that, so,
You want to see
No,
that?
I'll do a duo.
point of correction.
You do it. Running videos and half size. Down for tree line.
There's also.
Also, we have to do a lot of questions, so not worth it.
Yeah, we don't have to. The only time you have to worry about.
Well, no, like, back, but yeah, all the back, it's like all the. Oh, yeah,
Not even hard.
like, I mean, about like this much stuff to do, like,
No,
it's hard, it's
a pretty amount.
but it's just like.
Why do you have?
No, like we did.
Oh, I did too. Because we can make it so that we can find something like online.
Yeah. Yeah.
No, I also know this is.
I mean, it's still an enables, but you know, you only have, yes, the best problems in your. Don't take it that far.
Yeah.
Okay, you can take it.
Okay, yeah.
History.
I did text that next week and it was the following week.
Okay, can you send me a reminder, tell me what dates? Want to do it on?
Are you missing some of the noise?
Yeah, those didn't go too well.
I did bomb the using quiz looks back. It's actually my lowest grade in math. Yeah, from the area in line. I completely bombed it.
I remember that.
You really gotta recover.
I remember when I
did. And you did. I'm recovery. I got
That time, like, I unit one, you just had to about like the first 40 of them.
As like.
And I came back on unit one test and I bombed it and like from middle school, and I bombed that too.
Okay, yeah, I get that.
I think I actually got
Because he just left it here. Oh, yeah, I'm 100% taking that. Just yours, they're good.
Okay.
Yeah.
What I think I said is back that day.
Again, come back. It was good, bro.
Oh.
Okay.
Stop taking. Go take it. Next to this.
Yo, Nate.
Oh, yeah.
Yo, Nate, take your back.
I get the name. I get to be meeting apart. I'm shooting for A really right now.
I thought you had a Bible.
I don't know about the A. I'm really
Bro, you have a Bible. Very, very nice. Your face. You come in, your face is going to be, edit these entire spot wetlands and kind of organize it. Like Christian.
I've never heard you.
I've never heard
I actually, yeah, well, I was like, how? No, I was pretty